This is a recording of some stoichiometry problems I wanted to show you guys. So I'm going to use our mole map when I solve these. If we read this first question, we're looking for moles of hydrochloric acid, and we're going to try to end here. So the moles of HCl, that's going to be my B. And then I'm going to be starting with 7 moles of zinc. So that is my A. That's the one I'm going to start with. So I'm starting here with my A, my moles of zinc, and I'm going to convert over to moles of HCl. So when I do the problem, always, start with your beginning number over 1, and then we're going to do the mole-mole ratio. When we do the mole-mole, I like to do these just to remind you this is the only time we're going to use the coefficients. So this time we're going to use a 2 from the balanced equation. So there's 2 moles of HCl. I want to put my B on the top, and then I'm trying to get rid of the zinc, and you can see it'll cancel if I put the 1 mole of zinc here. So it's really then 7 times 2 with 2 sig figs. The answer would be 14. So let's try another. Okay, so let's try another problem. It's a little different. We are going to do number 3. And in number 3, we are starting with 3.6 moles of zinc. So this is going to be my A. And then we're going to go to grams of HCl. So that's going to be my B. So really we're starting here at mole of zinc. We're going to convert over using mole-mole to get to moles of hydrochloric acid, and then we're going to use molar mass to get an end here at grams. So I'm going to start with 3.6 moles of zinc. Always start with the beginning number over 1. And then I'm going to right away do my mole-mole. So I'm going to put in these coefficients. So 1 mole of zinc here from the balanced equation. And then I'm converting over to the HCl. So I'm going to put the 2 here, 2 moles of HCl. So you can see, like if I cancel, I'm at moles of HCl. I'm right here. But I want to continue because they want to know grams. So I'm going to know and calculate the 1 mole of HCl is going to equal the molar mass. And the molar mass you're going to get from the periodic table. Chlorine is 35.45, and then the hydrogen is about 1.01. So I get 36.46 grams. And then again, you can see these cancel, and I'm left with grams. So then I would just calculate it by multiplying 3.6 times 2 times 36.46. And then I also want to do my significant figures. I have 3 here, so I'll end with 3. So my calculator says 262.512, but I'm going to go and round that with 3 sigs to 263. Let's try the next one. So this one, it's the same reaction up here that we're dealing with. And I will erase it so it's not quite so messy. And we're going to start at hydrochloric acid is going to be our A. And we're starting at grams. So this time we're going to start over here. And then we want to figure out how many liters of hydrogen. So we have to go from grams of HCl to moles, do our mole-mole, and then it's a gas. So we're going to go here. So we're going to end here. So first thing, always take this over 1. I know the molar mass of HCl. I just used it up there. So 36.46 grams of HCl and 1 mole of HCl. So those cancel. I'm right here. Now I'm going to do my mole-mole. From my balanced equation, 2 moles of HCl. And then I'm trying to go to hydrogen. So this time I'm going to use, this is my B. So there's 1 mole from the balanced equation for hydrogen. So I would cancel. I'm sitting here at moles. Now I'm going to go down. It's STP. At STP, 22.4 liters is the amount of volume that any 1 mole of any gas occupies. So I'm going to put 22.4 liters of hydrogen, any gas, but in this problem, hydrogen is how much volume 1 mole of hydrogen occupies. So then those would cancel. I'm going to put this in my calculator, and the way that I'm going to do it is 59.7 times 1 divided by 36.46 times 1 divided by 2 times 22.4 divided by 1, and then enter. You can use parentheses in the denominator if you want to. So when I do this, my calculator tells me it's 18.33900, lots of numbers. So I'm going to want to have 3 sigs. So my answer is going to be 18.3 liters of hydrogen. Okay, for this next problem, we have a lot of different numbers here kind of going on. So we have 59.8 mils of 1.6 molar phosphoric acid. So phosphoric is this. So that's going to be my A. And then they want to know how many milliliters of 0.5 molar calcium hydroxide. So the calcium hydroxide is going to be my B. When I do this problem, I don't want to start with molarity. I'm going to start with volume, and I'm in liters of the solution down here. So that's the first thing. Make sure you convert this to liters. I'll just put that step in. Otherwise, just move the decimal 3 places to the left. So when I do this, I'll end up in liters of phosphoric. So I'm right here now, ready to use my molarity. My molarity is 1.60 molar, which means 1.60 moles of H3PO4 are going to be in 1 liter of the solution of H3PO4. So I'm going to make this into a conversion. I'm going to put the liter on the bottom because that then will cancel. And I'm going to put the 1.60 mole on the top. So by doing that, my mils cancel, my liters cancel. I'm in moles of the phosphoric acid now. So I'm right here. Now I'm going to do a mole-mole. And I'm going to put my moles of phosphoric, which if we want to call that your A, I'm going to put that on the bottom. And then I'm going to convert it to the B, which is the one I want to know, which is the calcium hydroxide, and there's 3 moles of that. So then I'm in moles of calcium hydroxide right here. And now I've got one more step, and I'm going to go down to volume. I'm going to use this molarity now, and I'm going to make a conversion out of it. So again, that 0.500 big M means that there's 0.500 moles of calcium hydroxide in a liter of calcium hydroxide solution. So this time I want to put the 0.5 down here, because then my moles will cancel, and then the 1 liter calcium hydroxide here. So I can see that my moles cancel. I end up with liters. They want to know milliliters, so I could calculate it and just move the decimal, or I could add one more step. There's 1,000 mils in 1 liter. So when I calculate this, you can just cancel out these two 1,000s if you want. You can multiply the top and then put parentheses around the bottom, or you could do what I call the zigzag. This times divided times divided times divided times divided times divided, and then enter. So my calculator, when I do either way, is going to tell me it's 287.04, but with my beginning numbers, I have 3 sigs, 3 sigs, and 3. So then my answer would be 287 milliliters.